The tiny world inside everything. Imagine everything around you. Your phone, your coffee cup, even your own body is made of incredibly tiny building blocks called atoms. These atoms are so small that millions could fit on the tip of a pin. At the center of each atom is something called a nucleus, like a tiny, dense ball. Today, we're going to explore how splitting these tiny nuclei can create the most powerful explosions humans have ever made. The special ingredient, uranium. Not all atoms can be used in nuclear bombs. We need special ones, particularly a metal called uranium-235. Think of uranium-235 atoms like overstuffed suitcases. They're packed so full that they're ready to burst open at any moment. When we collect enough of this special uranium and bring it together, something extraordinary happens. This is the key ingredient in most nuclear weapons. The chain reaction, one becomes many. Here's where it gets interesting. When we shoot a tiny particle called a neutron at a uranium-235 atom, it splits in two. But that's not all. It also releases 2 or 3 new neutrons. These new neutrons hit other uranium atoms, splitting them too. It's like knocking down dominoes, but instead of falling one by one, each domino knocks down 2 or 3 more. In less than a second, trillions of atoms are splitting. Critical mass, the magic amount. For a nuclear explosion to happen, you need enough uranium in one place. This is called critical mass. Think of it like trying to start a fire. With just one match, you can't create a bonfire. But with enough wood packed together, one match can create a massive blaze. In a nuclear bomb, when you bring together enough uranium-235 quickly, the chain reaction goes wild and creates an explosion. There are 2 main ways to build a nuclear bomb. The first is like shooting a uranium bullet into a uranium target. When they smash together, you get critical mass. The second way uses plutonium surrounded by regular explosives. When these explosives go off, they squeeze the plutonium into a tiny, dense ball, creating critical mass. Both designs aim to bring enough nuclear material together as fast as possible. When billions of atoms split in a fraction of a second, they release tremendous energy. The temperature reaches millions of degrees, hotter than the center of the sun. This creates a massive fireball that vaporizes everything nearby. The explosion also creates a powerful shock wave that can flatten buildings miles away, and dangerous radiation that can harm living things. The mushroom cloud we see is actually the hot air and debris rising up into the sky. Nuclear weapons have only been used twice in war, on the Japanese cities of Hiroshima and Nagasaki in 1945. The devastation was so terrible that the world has worked hard to prevent their use ever since. Today, several countries have nuclear weapons, but international treaties try to limit their spread. Understanding how these weapons work helps us appreciate why preventing nuclear war is so crucial for humanity's survival. The same nuclear technology that powers these devastating weapons also gives us nuclear power plants. These plants provide electricity to millions of homes. It's a reminder that scientific knowledge itself isn't good or evil. It's how we choose to use it that matters. By understanding nuclear science, we can make better decisions about our future and work towards a world where this powerful technology is used only for peaceful purposes.